Okay, so question 3 says an aeroplane is flying at a constant speed. The aeroplane is flying horizontally. The aeroplane's engines are producing a constant power of 5500 kilowatts and the aeroplane experiences a constant horizontal resistance force of 25 kN. Okay, find the speed of the aeroplane. Okay, so we know that when we have power, force and speed, there is a relation between power, force and speed. So we use the formula power is equals to force times velocity so force time velocity would be force horizontal resistance force is 25 kilonewton. So let's put them in the formula. 5500 V will be equals to power over force, 5500 kilowatt over 25 kilonewton. Let's cancel the kilos, so we'll be left with 220 meter per second. Okay, so this is part A. Let's do part B. Part B says the aeroplane then ascends 300 meter in 50 seconds. Okay, so that means the vertically it is ascending 300 meters in 50 seconds. Okay, so while maintaining the same speed, the resistance force is no longer constant and the work done against the resistance force in ascending is 300 meter is okay, the same 300 meter is 270,000 kilojoules. The mass of the aeroplane is 60,000 kg. Find the average power of the aeroplane's engine. Okay, so in these type of questions, what we normally do when there is a work done attached, there is mass, work done against friction or resistance. So it is better, the best way to do this is to use the conservation of energy thing, and in that after trying like many methods the best method that I got is to equate the potential energies, kinetic energies of before and after and work done by driving force should be equals to the potential energy after, kinetic energy after and work done by the resistive force. Okay, for before and after means if there is a journey where a body is is moving up an inclined plane or coming down over an inclined plane, or a question like this in which we have the aeroplane that is ascending. Okay, so potential energy before would be, we are considering a case like a plane is running horizontally, flying horizontally, and then it ascends. Okay, so when it was running horizontally, so we take to be relative potential energy. So initially the potential energy will be 0, because they say horizontally and they didn't given you what height it was. And finally the potential energy will be mgh, and now the height is 300 meters. Okay, so let's substitute that. 6000 is the weight, 60,000, sorry, mass. 60,000 mass times g times h, and that is 300 meters. So it ascends 300 meters. Then kinetic energy is, initially it was already flying, and the velocity was that we found to be in part A is to 20 meter per second. So half m is 60,000 and v square would be 220 square. Yeah. Then we have half. Again, when it is flying or ascending, this they say that it is at the same speed. So the same kinetic energy will be afterwards also. Okay, then we have work done by driving force. So what is work done by driving force here? There are two formulas for work done by driving force. In case of power, when they have given you the power, so work done is power times time, because they have given you the time and the power. So we use that version of the formula here. Power is, power is that we need to find average power of the airplane's engine. So power is that we need to find, so that is P times time. Time is 50 seconds, that is given here. 300 meters in 50 seconds. Okay, now what will be the work done by resistive force? So they have given you here, work done against the resistance is 270,000 kilojoule. So when you will be solving it, okay, this and this will be cancelled out, because before and after kinetic energies are same. P times 50 becomes equals to 60,000 times G times 30 plus 270,000 K. Kilo means 1000, so you can add zeros or you can just solve it otherwise. So when you will solve it all together, you will get power to be equals to 9,000 kilowatt. Okay. I hope you understand this question. This is part A and this is part B.